Hello there, geometry friends. Today's video is another video about angles and arcs in circles. So before we get to the new stuff, let's see what we should have recently learned. What you should have recently learned is what happens when you have angles formed by chords. What's a chord, you say? Well, a chord is a segment that extends from one side of a circle to the other. A diameter is a specific chord that passes through the center, but the chord does not need to pass through the center to be called a chord. So in this picture, Q, S, and PR are chords, and they intersect to form angles 1, 2, 3, and 4. The question here says, what are we going to do if we know that arc QR is 74, all right, and arc PS is 92, and we want to find the measure of angle 3. Well, I don't know what the measure of angle 3 really is, but I think I could find 2 or 4 because one of the rules is that the sum of these two vertical angles is equal to the sum of the arcs that they face. So x plus x equals 74 plus 92. So 2x equals 166. Divide by 2, and I get 83 degrees. Well, that's not what they wanted. They wanted angle 3. Well, I'm getting there. If I know that angle 2 and angle 4 are both 83 degrees, and then I realize angle 4 and angle 3 together make a straight line, linear pairs are supplementary. So 180 minus 83 is 97 degrees. So the measure of angle 3 is 97. So the rule is when you have chords that intersect inside a circle, angle plus angle equals arc plus arc. Then, what if I don't have chords? What if instead of staying on the inside of the circle, lines or segments extend outside the circle? Well, that's when you get a tangent or a secant. A tangent is a line that intersects, or honestly, a better word would be touches, a circle exactly once. And a secant is a line that intersects a circle twice. And the key word here is line. It means if you were to keep extending it forever, how many times would it touch the circle? So if I look at this first diagram here, that line looks like it's balancing on the circle. That's why when I defined a tangent, I said a tangent touches a circle once. Yes, it technically intersects, but it doesn't like pierce the circle. It balances on the circle, like if you put a yardstick on a basketball. All right, so this thing right here would be a tangent. This thing right here pierces the circle. That would be a secant. So if it balances, it's a tangent. If it pierces it, then it's a secant. So here, number 3, that's a balance, tangent. Here one, I have 2 here, 2 there. These are 2 secants. Down here, this goes through and it touches it twice. That's a secant. This line touches the circle twice. That's a secant. This line is balancing and only touching once. That's a tangent. And over here, I do have 2 touches, except both lines are balancing on the edge. So this is what it looks like if you have 2 tangents. Now, let's learn some rules. What if you have a tangent balancing on the edge, and then you touch a radius to that? Well, if you look at this picture, it kind of looks like that would be a 90-degree angle. And in fact, it is. A tangent to a circle and the radius to the point of tangency, those are perpendicular. Oh, I shouldn't have written perpendicular there. Pardon me, that should have gone there. And the measure of an angle formed by a line tangent and the radius is going to be a 90-degree angle. Okay? Now, what if instead of a tangent and a radius, you drew a tangent, but then like a slanty little chord? Well, what happens there is that kind of angle touches the edge just like an inscribed angle, and that's going to make this half of the arc. So x equals 1/2 y, just like if it were an inscribed angle. And you're thinking, wait, Mrs. Vibber, what's an inscribed angle? that would be like this. The one that touches the edge. This would also be x degrees. Now, you don't need to draw that if you don't want to, but I just wanted to remind you, as an inscribed angles vertex touches the edge and a tangent and a chord touches the edge, they have the same rule. So the measure of an angle formed by a tangent and a chord is half the intercepted arc. So if we come down here, this 70 touches the edge, which means 70 is half of the arc. The arc is z, so 70 times 2 is 140. Here's another one that says solve for A, B, and C. Well, these little dashes here mean that all those arcs are congruent. Well, there's 360 degrees outside of a circle. If I divide that evenly into 3 parts, it means each of these is 120. So angle C would be half of 120, which makes that 60. Angle B also touches the edge, so it's half of 120. And then arc A is 120. Okay, well, what if my angle isn't like on the edge and it's all the way outside of the circle? The measure of an angle formed outside the circle is half of the difference of the measures of the intercepted arcs. So if you have two secants, okay, and they meet outside, angle 1 is x minus y divided by 2. If angle 1 is here and it's formed by a tangent and a secant, it's still x minus y divided by 2. And if it's two tangents, right here, this angle 1 is x minus y divided by 2. But for this last one, I'm going to give you one special bonus rule. Now, you can do x minus y divided by 2. That totally works. But one other rule that works only for two tangents. Okay, so only for this last diagram, the measure of angle 1 plus y is 180. Okay, and I often describe this as the angle and the arc it's about to swallow are supplementary. Angle 1 plus y is 180. Now, how come that's true? Well, because of the other rule that says if I connect a radius to a tangent, I get a 90-degree angle. And if I connect this radius to that tangent, I get a 90-degree angle. That makes a central angle. And a central angle equals the arc. So this angle right here would be y degrees. In this quadrilateral that I just created, 1 plus y plus 90 plus 90 all have to add up to 360. Quadrilateral angles have to add up to 360. And if I subtract 180 from both sides, I get angle 1 plus y is 180. Okay, Ms. Remember, you said a whole bunch of stuff. Let's backtrack for a second. What are all the rules? Just give me the rules. Here are the rules. If you draw a circle with a tangent, if you connect a radius to it, 90 degrees. If you draw a circle, draw a tangent, and instead of a radius, make a chord, then if this is like 75, you double it to get the arc. If you draw a circle and draw a tangent and draw another tangent, if this was 60, this would be 120 because those add to 180. And then last but not least, if you draw a circle and make stuff intersect outside like this, and I know this is 100 and this is 30, if I want to find x, I do 100 minus 30 times a half. So that'd be 1/2 of 70, which is 35 degrees. Those are the rules. Let's practice using the rules. So if we come over here and it says find the value of y is outside the circle, so y is 1/2 the difference of the arcs. If the angle is outside the circle, the angle is half the difference. outside, half the difference. Outside, half the difference. So 110 minus 30 is 80, and a half of 80 is 40. Okay, now in this next one, it says first, what's the measure of AD? Well, if this is 100 and that's 85, AD is the rest of it, and all the arcs in a circle should add to 360. So 360 minus 185 is going to give me 175. So this is 175. And then it says find the measure of ACD. Well, that angle is outside, so it's half the difference. X is 1/2 of 175 minus 85, which is 1/2 of 90, which is 45 degrees. Number 3, find the value of W. Okay, well, look, these are two tangents. They fit that rule that we talked about a little bit earlier. 110 plus 70 does add to 180, but that's not what they wanted. They wanted W. Well, if I look at W, this side of the circle is 110. W is just the other side. So 360 minus 110 is 250. So that's W. Number 4, find the value of X. These are two tangents. So we can use the special rule that says these two add up to 180. 180, take away 35, is 145. Okay. I want to emphasize that you can only do that adds to 180 rule when you have two tangents like we do right here. Notice it did not work over here because we found that y was 40. And 40 and 30 definitely do not add to 180. Well, they're not supposed to because these aren't tangents. They are secants. Okay. All right, number 5, find the measure of the exterior angle. Well, X is on the outside. Outside angles are half the difference. So X is half of 125 minus 27, which is 1/2 of 98, which is 49 degrees. Okay, number 6, I'm going to change colors because this one's going to look a little bit different. So this one says angle CAE is 34. Okay, so this is 34, and arc BD is 24. Find CE. All right. Now, the rule is still the same, that the angle is half the difference, but my angle is already accounted for. So 34 is half the difference of x minus 24. So setting up the equation this time is a little bit different. So when I want to solve for x, the first thing I got to do is multiply by 2, which makes this 68. And then I have x minus 24, and I add 24, and I get x is 92 degrees. Okay. And last one, same idea. This angle is outside. The outside angle is half the difference of the two arcs. Now, I made a mistake. I did it on purpose because it's fixable, but I did make a mistake. It's half the difference of those two arcs. So when I write that out, these two things really need to be in their own independent sets of parentheses, because what I'm going to need to do is distribute this minus sign. So this 30 equals 1/2 of, well, 5x minus 10 doesn't have anything in front of it, so it can escape from the parentheses no problem. And then if I distribute the negative here, I would have minus 3x and minus 4. Then I would multiply both sides by 2 to get rid of this 1/2 and say 60 equals, well, 5x and negative 3x is 2x, and 10 minus 4 is 6. Then when I solve for x, I'm going to subtract 6 get 54 equals 2x, divide by 2, and get x equals 27. There was a lot more algebra in that one. And one way to make that a little bit shorter, if you wanted to, is another way I could have done this is start the same way, but then find the difference in my head. 5x plus 10, take away 3x plus 4. Well, 5x take away 3x is 2x. 10 take away 4 is 6. And you could have done that part in your head rather than writing it all out. Totally up to you, though. All right. So we are done with this lesson and those examples. There is some practice coming up next. Just remember, we now have to compare and contrast. When we have two crisscrossy angles and they're inside the circle, it's angle plus angle equals arc plus arc. But when our angles start ducking outside, then the angle is half the difference between them. Inside, angle plus angle equals arc plus arc. Outside, angle equals half the difference of the arcs. With that, my friends, I'm done. I hope you're having a good day and continue to do so. Toodaloo.